Good morning, everyone. I am Janina and I will be your host for this morning. Welcome to our first TechX event for this year. To officially open the program and to give us an overview, I would like to introduce the Director for Innovation and Entrepreneurship Directorate of the FEU Institute of Technology, Mr. Roland Garcia.
Hello, good morning. Can I be seen? Okay.
Yes, you can.
Okay. So good morning. Before we start the event, please allow me a few minutes to give an overview of the FEU Innovation Entrepreneurship Directorate and our efforts to create the next generation of entrepreneurs and innovators in the Philippines. This particular program is complementary to our nation building effort because we believe that nation building is best achieved through solving society's biggest problems, through creating jobs, using technology, innovation, and entrepreneurship. This is especially important during the COVID-19 pandemic, that there are a lot of problems and leaders and nation builders is at the forefront of stepping up to helping our particular country. Our mission in the FEU Tech Innovation and Entrepreneurship Directorate, in the Innovation Center, is to create the next generation of nation builders by creating innovators, technologists, and entrepreneurs. And the vision of FEU is to be the most innovative and entrepreneurial academic institution. And we are measuring this vision in 4 metrics. The first one is the number of technology startup companies established. So these are the companies that spring out from the university, from an idea, from a thesis, or just plain entrepreneurial talent of the students and even the professors. And from there, we want to be able to run them through the legitimacy of being a full-fledged company. And from there, we also want them to get funded, because one of the reasons why tech startups or startups in general fail is because of the lack of funding. So in the Innovation Center, what we want to do is to be able to create the ecosystem of investors to be able to help and enable entrepreneurship and innovation within the university and in the Innovation Center. Because of that, we also want to be able to count the number of new jobs created. We feel that this is one of the most important pillars of entrepreneurship and nation building, to be able to give opportunities to our countrymen and of course to be able to help the country. For the academic research that don't necessarily go to the corporate track or to the entrepreneurial track, we also want to count the number of innovations or patents applied for from within the university research. Currently, what we are targeting is an artificial intelligence research capacity for FEU, FEU Tech, and to be able to create a lot of trained AI engineers, scientists, and of course, new discoveries, new inventions, and new innovations from different engineering disciplines and different disciplines in general to help the Philippines. No? How do we want to do this? We want to do this in 4 ways. No? And the end result is to be the Philippines' first academe-based venture builder. Basically, we want to spring out more innovations, more patents, and more companies from within the university. 4 ways. The first one is our innovation and entrepreneurship curricular program. So we are infusing things like design thinking, lean startup principles, or even technopreneurship as part of the basic curriculum of the students. No? Whether you are a mechanical engineer, a civil engineer, a computer science major, a computer science major in design, right? You will have innovation and entrepreneurship classes that you will be able to express your ideas if you were to be, would be an entrepreneur. No? And of course, we have innovation ventures development programs. This is the program that we that will precisely be helping these entrepreneurs once they already have the idea and they want to formally enter a formal training, a systematic and methodical training to be able to work on their idea and receive help and have access to the ecosystem that we've built for these particular student entrepreneurs and even the professors. No? And in the future, we are launching the FEU Venture Capital Investment Fund to be able to fund these promising startups. No? And lastly, of course, we want to capacitate our research and technology transfer. Again, this is an institutional effort for the professors and even the thesis to work on emerging technologies, even deep technologies such as AI, artificial intelligence, data science, blockchain, right, drone technologies, and all the other emerging technologies, such as data science in our topic today, for the fourth industrial revolution. Okay. To be able to do this, we've partnered with one of the most successful startup incubators in the country, which is the AIM, Asian Institute of Management, Dado Banatao Incubator. And through them, through this particular cooperation and partnership, we are launching 6 programs under the Philippines' first academe-based venture builder. We have the first one today, which is TechX. Basically, this is a monthly talk. So watch out for our announcements for the next speakers. No, we are going to focus on technology practitioners, people who have deep tech knowledge, and the technologies we think are relevant for the fourth industrial revolution. Then this is open for everyone. The next one is Unmasked. We are having Unmasked, a second one, third week of August. So watch out for that. We have a very exciting guest for you. But basically, Unmasked is also a monthly event that talks to entrepreneurs who have made it, right, or who are working on exciting projects on their own. No, so Unmasked is basically a program, right, that was built because of the COVID pandemic. It means 2 things. Number one, of course, we are unmasking, of course, because of COVID-19. And lastly, because we want to unmask the secrets of how they became an entrepreneur, what was their journey. And of course, we want to be able to inspire future would-be entrepreneurs through this particular program. This is, again, open, of course, firstly to the FEU community and anyone who wants to be inspired to pursue entrepreneurship in the future. Startup Academy, of course, and the OJT, we are introducing a new OJT track. So before, traditionally, the OJT is working for a big company, right? But we thought that, number one, if you really have a good idea and it's worth pursuing, we felt that it's a good endeavor to be able to have an official track, right? To be able to create your own startup. And part of that track is interning or doing your OJT for a startup company, right? Because it's very different. The environment is very different in a startup company, right? So you'll be able to understand if you really want to be a founder in the future, you will understand how it is, no, to run a company from working very closely with the founders and even people who are building the company with the founders. Okay, and that said, we hope you enjoy the session today. This is the first session of TechX. We have a very, very exciting guest for you. So please stay and then enjoy the talk. No, so I'll give you back to the host, Janina.
Thank you, Roland, for giving that brief overview. So I know all of us are equally excited for our speaker this morning. So let me now introduce her, especially that we have a very interesting topic to be discussed. But before that, I would like to encourage all our attendees, so those who are inside this Microsoft Teams, to actually post their questions using the chat function, Or for those attendees who are watching through our Facebook Live, to actually use the comment section to post their questions so that we can give it to our speaker during the open forum. So, okay, with data science becoming an increasingly valuable resource, we wanted to talk about its importance as an emerging field in the country. Joining us this morning is the co-founder and CEO of Eskwelabs. It is a venture-backed data upskilling school. So previously, she worked across investment, management, and philanthropy in Canada and the United States. She was a co-founding member of an impact investing advisory firm for emerging markets. She is also a circular economy pioneer at the Ellen MacArthur Foundation. And through her previous work on sustainable oceans and finance, she was recognized by The Economist, by the UN Environment Program, and the World Economic Forum. So ladies and gentlemen, let us all welcome our speaker for this morning, Ms. Angela Chen.
Awesome. Thank you guys so much for inviting us. So Eskwelabs is a startup that is a part of the AIM incubator that Roland just mentioned. We are part of the cohort from last year. And I'm very thrilled to be here today to talk to the students and other practitioners from FEU about what we do. And I've been asked to give a short talk also as an introduction to the world of data science and the context of how that relates to the fourth industrial revolution. So I wanted to make it a bit more interactive. So even though I have some slides, there will be some opportunity for us to engage, and we'll use Mentimeter. So, do feel ready to engage and ask questions. And then towards the end, we're going to have elaborate Q&A. So you can save all the complicated questions at the end. But unfortunately, as we're going through the presentation, I won't be able to see your questions. So we'll just leave them to the end. So let me now share my screen. Okay, great. So let me first tell you a bit about what is Eskwelabs. And I think you kind of heard just now in terms of my background, it's a little bit unique that I'm working on this problem. So Eskwelabs' mission is to drive social mobility in the future of work through data skills education. And I think for me, it's a very personal mission. I had parents that were teachers. My grandfather was a principal. And I always, just instinctively knew the power of education in terms of transforming generations and really giving opportunities to tap into sort of the new, or growing economy. My family is actually from China. We moved to Canada because my father at the time was one of the first people to learn English, and then was able to, make these connections, and then was relatively easy move when you knew the language. To move to a different country. So I think that was 30 years ago, right? Now, today, the language that really matters in the future is the language of technology. It's the language of things like data. So that's one of the things I think would be very interesting to hear from you guys in terms of how you relate to that skill as giving you an opportunity in the future. So first, let's talk about the context, I guess, of the fourth industrial revolution. I know this is something that the event wanted to focus on. So it's impossible to talk about the fourth industrial revolution without acknowledging the other three revolutions that came before that. So there were disruptions around technology, and how we relate to those revolutions is really how it's changed people, how people work with machines, and how people work with each other. Right. So in the first industrial revolution, it was the steam engine. That is the industrial revolution that people think of. And then there was electricity manufacturing, and then there were computers. And then finally, the fourth industrial revolution now has to do with advanced technologies across some of these things that Roland mentioned and how they relate to each other. Right. So things that are, let's say, in drone technology, that relating to data, or biotech, that relating to data. I think one message that I do want to send, I think, is really data is the thing that underpins all those technologies. another great example would be like in robotics or IoT, right? The Internet of Things. So some of you guys might have heard of smart home products or might have smart home products where they will sometimes talk to each other. They will gather data about maybe, what temperature would you like your home to be, or what type of music you like listening to when you tell your Alexa to play a certain type of music. So let me tell you a bit more about why there's an explosion in data. But before we do that, I would love for you to go to this link so you could scan the code using your phone, or go to menti.com and enter the code here, 456391, and tell me a bit more about, what is an example of a data that is around you that you can think of, right? I gave one example of maybe Spotify collecting information about what kind of music you like to listen to. What is something else that you can think of that is from your everyday life? So just give everybody 1 minute to do this, and then we can see the results here. Sorry, let me just unshare my screen as you guys fill that out so we can go to the result page. Okay, great. So here's some of the things that you guys are saying. E-commerce data. Okay, yeah, when you purchase on Shopee, your location, social media, data collected by research. So that's quite interesting. That's probably something that you would have to go out of your way to do, right? If you're designing research. YouTube, social media, webinar registration. Yeah, definitely. Learning systems like Canvas. Okay, so some of you guys might be using that as a LMS. That's cool. And there's several stuff around social media, resume, medical records, personal identification. Okay. Right. And there's survey related. Okay, great. So terms and agreements. Okay, awesome, guys. So it sounds like that there is a lot of awareness for the data that's around us through different interactions that we have, but mostly is through some sort of tech platform, right? So Waze is an app, YouTube is a platform, and surveys collected through Google Forms. Great. Okay. Thanks, guys, for participating in that. Okay, so let's just contextualize that a bit more of like the explosion in terms of the data that is being collected. So I think you might have seen this, right? This, I mean, it's an exponential graph, but what it shows is really in the last 15 years, the scale of the explosion of data that exists out there. And one of the reasons for that is something that you guys alluded to in your answers is how data is being collected. So in the IoT example that we gave, you always had a temperature in your home, but previously there was no device to collect that information. And now with the explosions of ways to collect data, not just through IoT, but a variety of different things like apps, phone apps, and mobile becoming really like commonplace, that has really accelerated the collection of data. And so what's even more interesting is when we look at the, so it's not being put side by side. So let me just kind of point you out to where we are. So this is 2020, right? And this is about 47 zettabytes of data. So that's the year we're in now. And so if you come to this graph, we're here, right, 47. And in another 15 years, this number is going something like 50-fold, right? Slightly less than 50-fold here. And the other context, I guess, of why is there such an explosion of the availability of data, other than how data is being collected, is how data is being processed, right? So many of you guys might have heard about something called the Moore's Law, which is really about computing power and how that doubles every single 7 years. There's some people out there that are saying that's kind of being stalled now, but the other thing that's really enabled data processing is the use of cloud technologies, right? So maybe before it was very expensive for a company to get all these servers so that they can process the data, but now they can just sign up for Google Cloud or AWS and then be able to process that very cheaply. So the combination of those two things have really led to the explosion of data, and really want to convey to you guys that this is a big revolution that's underpinning the fourth industrial revolution, and that is going to have trickle-down effects in terms of how we work as humans, how we interface with that data, and also there are things that us as consumers, as individuals, also change for us, right? Like I think one person, an example, mentioned they get targeted ads through social media, for instance. So our shopping experience, our living experience, our experience being like a human in the 21st century is being changed by this explosion of data. And whether or not that's a good or bad thing, that is sometimes up for debate, right? But it's also something that if we actively participate in how that process will happen, we will get a hand, we'll get a say in what we want that to be. Okay, so let me kind of walk you through, and after this, actually, I was thinking maybe we can, it seems like there are a lot of people who are super engaged, so maybe after this part, we'll pause to see if there are questions from Facebook Live, or maybe we can already address them. So I want to show you guys kind of the progression of what a data science looks like, because there are many terms that are out there, and many definitions for what data science is. Right? Some people might think data science is like magic, like how do they come up with this prediction just using a bunch of numbers? Some people think data science is about statistics, and oftentimes I think when we talk to our students, they think data science has to do with coding, because that's kind of a skill that they normally associate with data science. But really when it comes down to it, it's not just a science, but it's also an art of using the scientific method, so things like hypothesis, testing, to really extract insights from data. So on that sort of scale that you see here, there are different stages of that. So in the very early stage here, we have descriptive analytics, right? So that typically would be a survey of, somebody mentioned Canvas, of maybe in this course, you were given a homework and you had to do a quiz. And the distribution is such that some people got a B, very few people got an A. That's what happened, right? So that's descriptive analytics that we're familiar with. Diagnostic analytics is similar to descriptive, but it digs a little bit deeper in terms of asking why, right? So some of you might be familiar with the framework of 5 whys. You keep on asking why. So in this example, let's say we had a class mark, right, that was given. There was a distribution, and what we saw was actually, hey, for this class last year, the last people who took this course, their average was 80 out of 100. But now with the same quiz that we gave in the same course, and nothing else has changed, their average is 70, and they're now doing worse. Right, so if you were the instructor, or if you were the TA for the course, you would kind of look at that data and say, oh, why did we think that happened? Maybe it's because of COVID, we're learning at home now, and it takes longer for people to learn, and they're not as engaged, and so they're confused about the topics, they don't have anyone to ask. So overall, the class is performing worse, right? That would be an example of a diagnostic analytics. Predictive analytics, exactly that. It's kind of asking what is going to happen? Right, so in this example, we can then maybe look at a single student and say, okay, given in the last 10 10 homework assignments, you were an A student, what would happen next? Is it more likely that you will pass the course or not pass the course? Right? So without knowing any of the other context, I think with the information that you're given, you're kind of thinking, okay, well, this is an A student, most likely they're going to pass the course. Right? So that's a very small anecdote, but imagine doing that on a mass scale. Imagine being the head of the school, right? And actually wanting to predict whether or not in this entire grade, how many people are going to graduate and go on to the next grade, or how many people even will be able to, let's say, get a job after graduation. So that would be a form of predictive analytics. And so that would be sort of like the bulk of what people think of when they think of data science. But really, we can actually go one step further to what is prescriptive analytics. So what that means is we were really then building like a data product. So in the Spotify example I gave, they are collecting information about what you listen to, like what happened, right? Maybe they don't know why it happened. They just know that you like this type of music. They're predicting that you will continue to like this type of music or artists that are similar to what you listen to. Then the prescriptive part is that, like a doctor, they're going to prescribe a playlist to you, right? That's why they show you your like daily discovery playlist of who they think you might like, and they're prescribing those artists to you by integrating that sort of analytics into the product that they have. Okay, cool. So I want to just maybe take a quick pause here. Maybe after this slide to see what kind of questions that people have about what we've shared so far. So diving a bit deeper in terms of like, okay, this is the scope of what people can do in data science. So who can become a data scientist, right? So data scientist, if data science is thought of as magic, then sometimes like data scientists are thought of as magicians, right? That they're doing something, like they're, going to a room and coding something, and then when they come out, they have a rabbit out of the hat. But in reality, like the person in the middle here that you see who is like the data scientist is very rare, because there's such a wide array of skills that you need to have to be able to go through the entire process. So I think the one that you might be familiar with is the hacking skills, which is skills that have to do with coding language like a Python or R. And then math skills is really kind of like the statistical concepts underlying some of the predictive models you want to build, right? So very basic predictive model might be like a time series model where it's just a regression. And as that becomes more complicated, there's the need for statistical knowledge is even more important. And so what I think people don't normally think of when they think of data scientists is this area here, which is the domain knowledge, right? So a perfect example might be, for some of the grads of Eskwelabs, they've gone on to work at banks and fintech companies where they're looking to build an algorithm for loan default prediction. So without having some domain knowledge as to like, how do loans work, right? How do loans work as a financial product? What are the traditional ways that a financial institution might actually look at default risk, right? Look at credit of a person. Without that type of domain knowledge, then it's very hard to build a data product on top of that without having some context. And that context is going to vary industry by industry. And having some of that domain knowledge would really help you in then bring together some of the experiments that you would have to run, right? Like as we talked about the scientific method, like what are some of the hypotheses you need to generate to run the test? You do need some of that domain knowledge to contextualize that. So when we get asked the question of like, I'm a fresh graduate, should I go into data science right away? There's either one of two answers, right? It's like if you want to really explore data science as a field, definitely you can go into a job right away and start as a data analyst, work on a analytics team. But if you are very passionate about a specific domain and using data science in that domain, then it's, my personal opinion, it's almost always better to get more domain knowledge. So then you can, level up very quickly in how you can apply data science to that domain. So for myself, for instance, like I have a finance background and I worked in an investment organization. And so having that sort of knowledge really helped me to contextualize, hey, if somebody is saying they can do a prediction on stock prices, do we think that's possible? Or what are some of the maybe caveats or risk to do with that sort of model? Because this is actually how the capital market system work for equities. And, you know, what sort of features might be important to that model would change depending on your knowledge of that. Okay, so if you want to, you know, for yourself, think about how I might become a data scientist or how I might get into the field, you can get a free resource from us on our website. We have a resource section where we have a free primer for careers, and it's really for, people who are early in their career. So I hope that will benefit you guys. So let me just take a pause here and then see if there are questions that would come in. Let me just unshare my screen. If there are questions on the Facebook Live or the guys who are in the Microsoft Team chat,
Actually, Angela,
yeah.
I myself have questions. Is that okay?
Yeah, that's also okay. I mean, we'll just take a pause because it's hard for me to know. I only see my screen. Like I don't see if people want to ask questions. Yeah.
So I'll ask the first one. So my background, of course, I'm an entrepreneur, right? But my background is in chemistry and bioengineering. How if I'm a student now, listening to this webinar, can I enter data science, and how deep should I go in terms of data science if ever I'm going to pursue a career in biotechnology or bioengineering?
Yeah, that's a really interesting question. I think if you are going into a STEM field, right, whether or not that's biotech or another form of engineering, or even if you're in something like thought of more traditionally, like more academic, like something like physics, learning the process of data science is very helpful. Because learning the process of the data science, even if it's not in your day job, it helps you formulate experiments. It helps you become a better scientist, right? Because we're using the scientific method. And it also better helps you almost like prioritize on what you should do, which I think in the context of startups, right? Like one of the things you mentioned is like teaching people the lean startup methodology. I think that's quite important because I think people don't realize like where to start, right? So let's say if today I was to start a business, and I know one of the things you mentioned in the beginning is like, you know, startups can grow as fast if there's no funding. I think another big thing with startups is startups can grow very fast if they're solving a problem that no one has, right? They're creating a product that nobody needs. And so how might you actually use data science to create that product, right? How might you actually use data that's collected from potential customers to evaluate that and then consider, hey, what is this data telling us in terms of what type of product do people want? So even if you're like a business person, like an entrepreneur, you would still need to learn the process of data science as well to do that better and to do that in a more like lean manner.
Yeah. The stages of analytics, the descriptive, diagnostic, predictive, and prescriptive analytics. Which part there, as a student starting out in data science, which part do you think I should start with, or with which among the four?
That's really interesting. I think like from our experience, what we see is the capacity to ask questions is a definitive characteristics of good data scientists or good data people. And so what that would then reflect in terms of the stages would be the second stage.
Okay.
Diagnostic stage, right? Because the first stage, like most people would be able to do that, right? So like, hey, let's look at the COVID chart. What happened, right? We have maybe death rates are plateauing, but infection rate is going up. Where most people stop is there, right? Because when you read the news, that's kind of the news stops there. Like in the headline, it's like, this happened. Maybe there was a response from somebody, right? And that's where we normally stop. That's like normal, everyday kind of interaction. So where people stop is they don't ask why. Hey, why is it that the death rate has plateaued, but infection rates were going up still? Right. So I mean, like a real example of what happened during COVID. And then when people dig deeper, and this is for certain countries, when people dig deeper, oh, why is that? If you just ask a question, oh, why is that? Oh, it's because actually the death rate before was very high because there's like all these older people, but now a lot of young people are getting sick. But when they're getting sick, they're not dying. So that's why even though we have infection rate going up, this is plateauing. Then you ask why again, right? With the 5 whys, like, oh, why are more young people going out? Oh, because like young people, they just like, they have more touch points. They're like hanging out. They're, maybe disobeying the quarantine. And that's why they're getting sick, right?
Yeah.
It's like, well, why is that? Oh, maybe because like they don't have school. They don't have a place to meet and gather. And so now this is like their outlet. And you can kind of ask questions like, and you can see like from a policymaker point of view, how that might be very important.
Yeah. I think a lot of organizations now, especially the big ones, are already shifting to a data science culture. And this is why, for example, Stephanie C of Thinking Machines, right? Her company is doing well. So if I'm an engineer and I want to be trained in data science, how can Eskwelabs help me?
Yeah, for sure. I mean, I'll kind of share a bit of very concrete stuff at the end in terms of like our programs and even like free resources you guys can access.
Yeah.
I think to start with, and this is getting a little bit into like the career part, which I personally love. I think it's very important, especially now, like for people who are graduating very soon or, about to graduate, to set some sort of direction for themselves, to set a direction of like, where do I want to go? And don't just come to data science because, you read somewhere that it's the sexiest job in the 21st century, and don't do this because you heard it from us, right? So let me just, okay, so I think this is a good segue. So let me just go back to the slides.
Go ahead.
And then I'll kind of continue, but I'll show you guys a chart. I think that's pretty interesting in terms of like career growth opportunities in this space. Okay. Sorry, it froze. Yeah, I think it's presenting now, right? Okay.
Yeah.
Okay, so guys, this is data that I just screenshot from Google Trends. So this has to do with search words that people are putting in Google. And this was, I just showed it, I think, for globally, not just the Philippines. But I wanted to show this to kind of highlight the really like growth potential in the data space for a career. So the blue here is data analyst, the red is data scientist, and the yellow is financial analyst. So I show yellow because when I entered school, that was what people wanted to do, and that was a reasonably respectable job that had good growth potential in finance and in investment. But really, you can see like over the last 5 years, which is I guess what we care about, right? Because right now we're still in school. The yellow is pretty much like very steady. It's not really going down, but it's not going up either. But you can see here around like the 2017, 2018 mark, this is when like the data jobs made a break. And even now we know, for instance, like data analyst is just recently was named like one of the top 10 jobs with the most number of job openings globally by LinkedIn, right? So relating back to, I think the question that Roland was asking, like, how can I interface with data science if I have this type of background? I think you can think of yourself as doing data in a specific sector. Like if you have a bio background, you can be doing things that, with a title of like a data analyst or data scientist in a biotech field, right? And that's really, to my point of like setting a direction for yourself, like if this is something that you would really enjoy doing, now is really a great time to start thinking about like, how can I move myself in that direction? Because there will be a lot of career opportunities for you to grow even more in terms of your skills, but also to, learn from others in the space. Okay, great. So now I want to transition to I think what you guys wanted to learn a bit more about, which is the data science process. So just check the time. Okay, so I will take you guys through an example of a project that one of our students did. So typically there's 5 processes in the data science process. So the first 3 steps actually take up most of the time, even though the later 2 steps are the more glamorous aspects of when people think about machine learning, the models that have to do with that, and then deploying the model. Some of you guys mentioned surveys, right? Like an example. So surveys are a perfect example of collection of how are you going to get the data, and then once you get the data, maybe you have a case where, let's say, where do you live? And somebody put NCR, another person put Manila, another person put Makati. Then all those things are technically kind of overlapping. So then you would have to clean the data. That's the least favorite part of most data professionals, but it's just something that needs to be done. And even when we talk to data scientists at large tech companies like Facebook, for instance, when we have our within our course these industry meet and greet sessions, they also share with us that even at Facebook they're cleaning data for a big chunk of their time. So it's a really integral part of the process. Then what happens next once the data is ready? You have the sources, it's clean, it's ready for use. Then you go into what is called EDA, or exploratory data analysis here. So this is the part that's quite important. This is where you're asking some of those questions, those diagnostic analytics questions, oh, why are we seeing this? Oh, that's really interesting. Can we look a bit deeper? Can we segment the data a bit more if it has to do with customers? Can we look at how it relates to geospatial, right? So maybe plotting the data that you have on a geo map and looking at if there are certain insights that you can just glean from looking at that visually. So that's also where some of the data visualization stuff come in. So this stuff that we just did right here, that's a perfect example of an EDA process, right? We just looked here and we say, oh, okay, this is what it looks like. The model building process then will involve you identifying for what you're trying to predict. And this is if you're going into the predictive and above part of the analytics, what type of model would you use, right? Is it something that you would need a decision tree type model, like a machine learning type model? Is it something that is supervised, unsupervised machine learning? The nature of the problem will really prompt what kind of model you would have to build. So during this part, there's going to be a lot of testing, a lot of feature engineering. That's what the engineering part means when we think about machine learning engineers, right? Tweaking the factors, inputs into the model to get a better result in terms of accuracy and just the predictive power. And then finally, the model deployment has to do with the integration of it into a product, into a data product, or it has to do with the integration of it into a system that you have if it's just an internal thing in the company. So in the bank example we gave, once we have built the model for predicting loan defaults, then we want to deploy that model into our loan process, so then our loan officers can use that in their day-to-day job as they're talking to potential bank clients who want to receive a loan. Okay, so it sounds a little bit abstract, so I want to showcase an example for you guys. All of our fellows in our data science program do a capstone project, which is a graduation project that they either do by themselves or with others in the class. And then also they do about 10 hackathons, which they have to go through this process. But I will show you an example of a capstone project that was quite fun and really relevant for what's happening now, because the SONA just happened last week. But I also want to show this example because to really kind of show that the first 3 steps are really the foundations. And sometimes you might not even have to build a model. Sometimes you're not doing predictive stuff, right? You're just really exploring. And then based on the exploration, you can already come up with recommendations for what you want. And that might already suffice. Okay, great. So this is Karen's project. And that's related to the UN SDGs. So what she wanted to do was she wanted to analyze the State of Union addresses from presidents in the last 50 years in the Philippines. And the reason why she wanted to do that was just to really highlight some of the, well, first she was personally interested to kind of see like how did the SONA change over the years as presidents change, but she also wanted to do the project to inform citizens to get more involved in politics and to highlight the sort of some of the issues that are being talked about in the SONA. So it was really like a citizen project. So there was no business context in terms of business value being generated. Okay, so her methodology, so you can kind of contextualize this based on the process I just shared with you. Her data gathering was web scraping from the official Gazette, where all the text version of the speeches were there. Then for the bulk of her project, she was using what is called natural language processing method. So that is what is essentially a way of working with words as data rather than working with numbers as data. Right. So typically when we think of data, it's really like structured data that we're thinking about, which means that you can put it in a table, like an Excel file, right? And you have like rows and columns. But one thing to do with the explosion of like the availability of data that we talked about is really the use of unstructured data. So data like words, right? In this case, these are the words in the speeches of the president. So in that, for her processing, she cleaned the data, she used NLP techniques like lemmatization, tokenization, and she also ran some models to do the text analysis in terms of the sentiment of the word. Is it a positive word? Is it a negative word? She also did something around readability, which I'll share in a second. Great. So this is actually, yeah, it's supposed to move. So this is like a word cloud. So at least just, basically she extracted the words and just by the count, right? What are some of the words that are being used by the different presidents? So that was a big part of what she was trying to find out in the EDA process. What were the presidents saying? So she looked a bit more into this and she realized across all the presidents, economic was the most frequently used word. And then she actually overlaid that with how the economy was doing at the time when these words were being used. And she used metrics like GDP growth, which is, a typical thing economists look at, and then the inflation rate. So you can kind of see here during this like very late stage of Marcos, this is where the word economic was used the most often. And it was also at the time when the economy was doing the worst, right? Here's the GDP growth rate, it tanked in this period in the mid 80s, and the inflation rate spiked in this period. So it does look like that. From here, we can like glean, right? So we think about the diagnostic thing, we're asking like, what can we glean from this? Oh, so actually the presidents and their speeches are reflecting a little bit of what's happening currently, but we do maybe see there being a lag, right? So maybe it's like, the speech is written also about the thing that happened last year, or so it's not exactly real time, but we can see that just from this EDA process. Then she looked at how are they saying it? Oh, which I think we skipped that slide because we don't have time. But in the how they're saying it, it was looking at the sentiment analysis of presidents and whether or not there were presidents that were consistently very positive in the words that they chose to use for speeches, and if there were words that were, if there were presidents that were using more consistently negative words. So we'll just skip to the last part, which is who was their audience at the time. So this, I think, to me, was the most interesting EDA from the project. So it was something that was a readability score called the Fletch-Kincaid grade level. So this is a way to evaluate how difficult were the words that were being used. So you can kind of see very clearly from this visualization that there was a decline in the difficulty of the grade level, which is on the scale, right? So these are actually grade levels. So here in, as recent as 2019, the grade level from Directorate speeches were really at a grade 8 level, where I think it could have been even a bit lower, like grade 5 level, versus the early speeches from Marcos were really at a PhD level, right? They were at like a postgraduate academic level. And that, tells us that presidents have been progressively speaking more to the masses, but then maybe like, a few decades ago, they were only speaking to the elites. So from there, she created some data projects that were interactive visualizations that exist as a product online. People can go and click on these words and kind of see how the use of these words have changed over the years. She also built something predictive, which was essentially AI-generated speeches that used words from each president, and you can read the text and then guess like which president might have said this, given these were the words that they used during their tenure. Cool. So that's a very short overview of the project, and there are a ton more projects like this, and you can actually go and look at our recent projects on our YouTube channel, which is just, Eskwelabs, on similar projects related to politics or other things that are, related to everyday data. Okay, so let me now quickly, I guess, talk to you about what it is that we're doing at Eskwelabs and like how you might be able to get involved. So our approach as a data-focused upskilling school, as I mentioned in the beginning, is really about democratizing data skills and how that could help drive social mobility as more people can, get involved in the future of work. One of the reasons why we pick data as something to focus on is also because of the flexibility of what I just explained in the data science process, right? We have people who are cleaning data, we have people who are analyzing data, we have people who are predicting data. What's really important to us is looking at affordability of the education, effectiveness of the job outcome, right? Because those are really the two things that I think students are the most worried about when they think about investing in themselves in terms of education. How much is it going to cost, and is it going to work? Right. And then finally, the third thing is really what we love from learning, which is like, having friends, getting together, having fun together and learning together. And that's something that even though, COVID is happening now, we really care about that and want to keep that peer community there for life learning. So based on that, what we really focus on is the community aspect of being able to not just like learn the skills, but for you to be able to like graduate into a world then you already have friends, both socially in the field of data science, but also like professional colleagues, as now like some of our grads are working in the same company. We also, of course, like education is a huge part of it, and because it's structured in a bootcamp format for the data science program, it is an accelerated program. So we do look at, let's say, these are the skills that industry needs. We have an industry council where companies tell us what are the skills that they want. And we, in the shortest period of time, teach you the important things that you didn't know. And so you can like get on the job and really quickly continue to learn like what is needed on the job. There's also a strong focus around data science for good, right? So some of these projects that I showed you that our fellows do are not related to a business context because they can do that on the job, right? But they want to explore like how can data science help the Philippines, which is something that we're very passionate about. And then finally on the outcomes. So 90% of our grads so far have been able to land a data science job within 90 days. And we also really saw that they saw a significant increase in their pay, which you can kind of see from this distribution from before and after Eskwelabs. And the fellows typically graduate into either a more traditional space, so like working at, let's say, Union Bank, or the counterpart of that would be like a fintech company, right? Or they, also have the opportunity either like within the job or, as one of, as like a main pursuit to work in consulting. And that's typically for students with a bit more domain knowledge as a background. Great. So I want to just pause here and kind of see if you guys want to comment on like how you relate to the idea of data literacy, right? Because as we're kind of talking about data science and in the examples that we used around COVID and how citizens can engage with data, a lot of the stuff that we're talking about right here is still a little bit far away and removed from people's lives. When we like distill data science down to a more like, everyday level, it means data literacy. And that's really defined by the ability to read, work with, analyze, and argue, right? Like have that question, sort of that question relationship with the data. So since we talked at length about like diagnostic analytics, I want to just take a pause here to kind of see like what are some of your ideas around how you could apply the idea of asking questions about data in your life, and how can we, what are some of your ideas around like building a culture of asking questions about data that could help you maybe personally, help your school, maybe help your family, or like help our society as a whole? What do you guys think about that? So I don't have a Menti for this. I was hoping that we could see the comments, but I guess that might not be possible. Maybe we can start with Roland and see what Roland thinks.
What was the question again? Sorry. how can I,
how you relate to the idea of kind of what we talked about around like diagnostic analytics? Like what are some ways you think we can encourage people to ask questions about data? How can you apply the idea of like, you know, data science, data literacy in your life? Or what are opportunities maybe you see at the school, or just even in like our community as a whole?
Yeah. So that like for now, right? Because of COVID, I think because there's a lot of data that people I don't think completely understand what the graphs mean, what like when the WHO says that we need to flatten the curve. I don't think 90% of the Filipinos really understand what it means to flatten the curve, right? So I think so number one for COVID data, people can definitely learn to understand, learn to question, and as you said, learn to argue with data, especially right now with a proliferation of fake news. When people see sort of numbers, for example, from the DOH, they sort of accept that as Bible truth, right? Which I feel like, at least in this particular government in the Philippines, I know you're not Filipino, you're Canadian Chinese, right? But in the Philippines, there's some level of doubt, especially in fake news, right? Secondly, I think because the elections are coming up in 2022, we need a data literate population. Especially when the polling comes out, right? It's funny because my twin brother owns a political data science firm, right? And they do a lot of polling, right? And they have their own software and all those things, right? So when they release these surveys, right, the survey results, no, again, people will think it's Bible truth, right? But it's just one side of the story, right? So I think applying that, cascading to the 2022 election next year, I'm sure that we're going to see a lot of data pertaining to political sentiment analysis of the population, and that people don't know how to read that, right? People don't know how to read graphs from DOH or WHO. People don't know how to, like, at least for that particular example, people won't learn to argue with one-sided surveys in politics. At least those two that are pervasive societal issues. No, I think we need to have a data literate population.
Yeah, exactly. So I think the flatten curve is really like the perfect example, because without having some even knowledge about how statistics works and just a normal distribution, right? Like distribution is the curve. You don't know about distributions and like what is the curve? It just seems really conceptual.
Yes.
So yeah, I think that's really.
I'm sure people are asking, why do we need to flatten the curve? Is that a good thing, right? Like because the media says we need to flatten the curve, then everyone says, okay, let's flatten the curve. But I don't think they really know what it means operationally, outside of the numbers, manifesting in physical reality. You're correct. It's very conceptual.
Yeah, I'm seeing some of the questions come in, and I'm wondering if there is there's probably a good opportunity to go like all of them. I guess very quickly, I think I'll just address one of them. I have one last slide I'll share with you guys, just in terms of like, if you are very excited about the space, if you're very excited about what you heard today, and you want to get involved right away, there are two ways that, we would love to invite you to get involved with what we're doing. So here. Okay, so the first opportunity, I would just start maybe like on this side. So I know I saw one question that said, hey, do you need to know coding to start with data science? You definitely don't need to know coding to start, right? Because what we showed around the first two stages of analytics, you can already start just by looking at graphs. You can already start by asking questions in the news of things that you see that are being presented. The data science process is not about coding, right? Like that's, I think, the biggest mistake that people make. But to become a data scientist, to work with machine learning algorithms, because the amount of data that you're working with is huge, the volume is huge. There's limitations with using tools that you might be using right now, like Google Sheets and Excel. We have to use coding language like Python to better manipulate the data and better wrangle the data. And so in that aspect, it is very much preferred for you to have some, hacking skills like I showed before. So we have a free prep course that you can join that has, content from us, and we regularly do live tutorials. And so you can, join that by just going to this link. So just go Eskwelabs Ara. It's something that we really, really pushed for, especially during COVID, and we've made that available to a lot of people. And so far, there's been, about 2,500 people that have interfaced with the Ara program. And so there's actually two things that are available. One is the one for Python. I mean, this one, it's the same content, but what you're seeing there is really, it's a prep course for our data science fellowship. And then we have another free program, which is for digital careers, because we saw during COVID, many people no longer have the opportunity to work an office job, and they have to look for a job working online. So that may or may not be the case for some of you guys. Maybe you're looking for internship, thinking about maybe how I can take on a freelancing job. And it talks a little bit about, how you might be able to do that more from a career perspective. So that's a free resource for you to take. And we also have a Facebook community of people who are learning Python together, so that you can join that and get some resources from there. The other one is, if you're interested in this idea of using data to improve our communities, we are running a Data for Good hackathon with the United Nations Sustainable Development Solution Network. So it's a group activity in which you can, recruit your friends, and there are going to be people participating at all different levels. So we will have people who are going to be at the diagnostic stage, right? So maybe looking at COVID data and asking how can our policymakers make better decisions. But then there will also be people who are at the machine learning level who will be making predictions, and they would all be centered around any of the themes related to the UN SDGs. So that's actually happening this month, and we are going to release more information about joining at the end of this week. So, if you are interested in just trying your hands at the data science process, this would be a really great opportunity. Okay, great. So that's it for me in terms of my slides. So I guess maybe now we can, go into the
can do the conversation. I think there are a couple of questions. So you answered the question from Dara Hicap, from Facebook. But I'll go on and ask you about the question of Charles. So this is his question. With all the information available for analysts, how do you know which ones are pivotal in making decisions with the information available at hand?
Yeah, that's a really good question. And I think it's related to some of the other questions maybe around hey, curiosity is such an important part of data science. How can you develop the mindset for that, right? And also even, how do you become literate in data? So definitely it starts with your mindset, right? Yeah. So much of it has to do with what to remove rather than the other way around, right? Because we talked about there's an explosion in data. So it does make sense that there will be a lot of data at your disposal, especially if you're in a company, right, where these data pipelines already exist. The first step, I think, to start with is like, we're not doing data science for no reason, if that makes sense. Like, and that's what I mean by like, don't get sucked into this idea of like, this is just a cool job and I want to do this. Data science is for people who want to solve problems. Data science is always done in the context of what is the problem. So for instance, like Karen's project, she did that at a time when, so in her class, there were actually 2 fellows who worked on sonar related projects. And the reason, because this was, there was a celebrity scandal, I think at the end of last year, if you guys remember, that took over the I guess the popularity in terms of like Twitter and all those stuff, and people were not really paying attention to the Sona. So really in their mind, the problem that they wanted to solve was, I want to educate people about the Sona, right? Like I want people to know about what's happening. And so that was more of a personal passion context and really more like citizen-based. But in the business world, companies are not hiring data scientists for fun, right? Like they are looking to solve a business problem, or even in government, right? Looking to solve a problem, whether or not that's generating more revenue for the company, that's looking at ways to optimize processes and automate certain tasks, like in the bank's instance, right?
Yeah.
Bank instance, I guess it's business value on both sides. But it has to start with, what is the problem they're trying to solve, right? And maybe sometimes data is a part of the answer, and sometimes it's not, right? So if you start with that sort of mindset of like, what is the problem, right? Because that then helps you develop the curiosity mindset, because one person might say, this is a problem. But another person might say, another thing is the problem.
Yeah.
You have to keep asking them why. So once you figure out that as the context, that's when you then find out like, what would be the factors that are important to making a prediction. I can give you a very interesting example that is very non-business based, but it's also a project that our fellows did. So it was actually a partnership with a company. It was actually an insurance company in the US that wanted to understand if they can better predict premiums that are given for property insurance. These are like car insurance, health insurance. And that was actually, they wanted to look at the crime rate. District of DC in Washington.
Yeah.
And they wanted to understand whether or not, they wanted to understand if they could predict crime. So then this is really interesting now, because then your mind right now could go everywhere. Oh, how do I predict crime? Like, let's find out where the criminals hang out.
Yeah.
Right? Let's find out other things. But the scope of the project was related to the property. So then that eliminated some of the controversial stuff, I think, that you see with like data privacy, how maybe data is misused around like racial profiling, for instance, right? Like if you're trying to predict who is most likely going to be a criminal based on like, who in the past were criminals. So thus we extrapolate their characteristics and we think like this group of people are going to be criminals. Like that's the mistake I think people make, right? But in this case, it's really about the property itself. So the factors in that case they looked at were really environmental factors. So for instance, they discovered through the EDA process that car theft, like people breaking into a car and like stealing something, those happen disproportionately near like subway stations where there is a getaway transportation, right?
Yeah.
So then they like narrow down the type of data that they would be looking at because the context is narrower and the scope was narrower and the problem was better defined.
Yeah.
So I hope like that is an example that answers both those questions. Like, how do you become more curious? Like, you just keep on asking questions.
Yeah. Interesting. Okay. Okay, let's go to another question. Probably ask you three more questions. This is from Ronald Halili. This question is, what caught my ears earlier was when you mentioned using data science for stocks. If I wanted to jump into data science for that, what direction could I go to so I can start?
Cool. I think it depends on if you are thinking of, building something yourself to do day trading, or you're thinking of entering it as a job. So entering it as a job is really interesting and quite exciting. It's something that I think, unfortunately, is in very nascent stages in the Philippines because the equity markets here don't have very high trading volumes. And that's something that you would need a very deep capital markets to get into. But that's a real job. That's what is called algorithmic trading. And it's actually, most traders now are actually robots rather than people. And the existing traders who work on that as a real job, they use these tools to then enter and make calls on their positions in the market. If you're stock specific, if you're looking at doing it yourself, my personal opinion is that it depends on what you're trying to do. If you're trying to do day trading and trying to beat the market, there's been already a very deep field of people who are trying to use statistical methods to do that, in technical analysis of stocks. So you can start with that. So it's like a black hole a little bit to go into. If you want to get into that, you can do that for years and still not really find the answer, right? Because it's just so dynamic. As something real time, and there's so many multiple factors that's involved in something like stock prediction, and that's why there's a huge financial industry that's built around that. And whether or not data science can replace stock analysts in the future is something that's actually being really heavily debated in the finance industry. It's something I find personally very interesting. The area where I think there's more potential is looking at alternative data sources for research analysts to evaluate companies. Mm-hmm. Not on the basis of day trading, but really figuring out the true value of a company. And so one example I can give you is, for instance, companies report quarterly earnings, and analysts sometimes have to wait until that time to figure out if their forecasts are correct, right? So let's say before COVID, for Walmart, if I was an analyst covering Walmart, I would then have to, pour over their financials, maybe get on some calls with management from Walmart, and also look at economic data to figure out, hey, are people shopping at Walmart? Do I think Walmart is going to have a good quarter? Right.
Yeah.
So now what some of the analysts are doing is they're using satellite images. They're using satellite images of parking lots at Walmart locations, right, where they can actually get those images and kind of see over time how many cars are parked outside this Walmart. They, based on historical sales, can have some, general correlation, right, between the number of cars that are in the parking lot to the number of people shopping at the Walmart, to sale per person, to estimate the sale per store. And so that's a way that data is really giving certain analysts an edge by getting that information faster, because they're getting that information now real time from the satellite images, and they don't have to wait until the quarterly earning call to hear from the management and say, oh yeah, we don't have people coming, right? So that I think is quite interesting as something to explore.
Cool. Okay, there are a lot of questions here in Facebook. Okay, I'm gonna pick one from Jan Nell. How does one become literate in data? I think this is a good question for everyone.
Yeah.
I think I'm for the information of everyone. I think there are 200 people watching now. Yeah. Data is the new oil, and as Angela mentioned earlier, data science is the sexiest profession of the 21st century, regardless of what industry you're in, whether you're in engineering, whether you're a civil engineer, all of these, or even entrepreneur, a business person, advertising, all of these professions already use data. And I think this is a very good question. if you're not formally trained in data science, no? So the question of Janelle, how do you become literate in data?
Yeah, so that's super relevant. And I think like the definition that I shared earlier, just to remind you guys again, like data literacy means the ability to read data, to work with data, to analyze, and then argue with data, right? So there are three elements there. So, I mean, in one short answer, it has to do with practice. Just in what we kind of said in the beginning, like data skills, having these skills, that's the equivalent of a language skill, decades ago. And how do you learn a language? You speak the language, you practice the language, you get into situations where you have to use it, right? So it's very similar in that way, that if you don't use your brain, if you don't use your analytical brain to question things that you see in the news, if you don't use your discerning eyes, when you look at data visualization, like, maybe that's not correct, then you don't get better because you're not practicing the language. So I think if we think of it rather than a skill, like as a language, then you can kind of think of it as also like maybe there are certain vocabularies that have to do with data, right? Like when we talked about like the curve, like what is the curve? Distribution, like what does that mean? So there are also certain vocabularies that have to do with data literacy that underlie some core concepts that you would need to learn. I don't know if it would be a good analogy, but it's like grammar, like like language. And once you know grammar, you can like make new sentences. You can analyze different things.
Yeah.
So you can use the same skills to analyze stocks as to analyze COVID. So it becomes like interlinked, but ultimately it does require work.
Yeah.
Let's just say that. It doesn't mean that, hey, you come to this webinar, you heard us talking about what data science is. Definitely from this, you gleaned a bit more about what is the data science process. And I think that, helps you to get a bit more data literate because now you're aware, right? Yeah. But it's not going to be as easy as that. You do need to practice just in a language where you have to speak the language to get better at it.
Yeah. Question from Sut Ilay. I'm not sure if she's Chinese too. But this is her question. And I think the question is more of if she wants to get a data science job, right? Where can I get some solid experience and what qualifications should I be looking at?
Yeah, I think those are probably questions for any job. Question. So that's why I think I said in the beginning, like it's really important for you to set a direction for yourself. Not just saying, I want to do data science, but like, what is it that you're interested in? Are you interested in data science for finance? Are you interested in building a product, like building a tech company using data science? So that will narrow down your scope. And honestly, guys, like you can use the data science process to figure that out for yourself. I'll give you the perfect example. In Eskwelabs, before we developed our first curriculum, we actually did our own data science project. We scraped the website of JobStreet, LinkedIn, and Caliber, and looked at jobs that were tagged as data scientist jobs. Then we used NLP techniques, which were the same as the ones that you saw in Karen's project, and we analyzed the texts that were in the job descriptions. So hundreds of job descriptions, we looked at that, and we said, hey, what are companies actually looking for? Like, what are the skills that they're naming in the job description? So you don't need to do that, right? Because it's like overkill. But what you can definitely do is go to those job sites now and look up 10 jobs, right? That's a small sample size. Technically, it's not statistically significant, but I think it's fine. Just look at 10 jobs and then look into the job descriptions and see like, what are they asking for? Are they asking for people with more math skills? Like, how many of the skills do I have? And even using that, you can kind of see like, well, what am I excited by? Do I really know? Maybe you're not applying for a job now, but you can glean from that using that data science mindset, right? The mindset of asking questions, mindset of being curious. Go and explore those. And then make up your own judgment of within this field of data, doing something like this as described by this job description, for some reason that really speaks to me, and I want to do that. Then you can then work backwards, right? Because that's maybe like the milestone you want to hit. then you can work backwards and say, okay, well, I'm here. This job is asking for these 5 things. I don't have these things. So what am I going to do to get those things so I can become an ideal candidate for that job? That, you guys, like, is the data science process. And that's, I think, so magical about it as a way of thinking.
Yeah. I think a complementary question to this. So he's an undergraduate student. He's from Kevin Francisco. This is an interesting question. No? So I am taking up. Hello, I am a student taking up BS Applied Math, and data science is my track specialization. Is there any advantage or disadvantage with taking up this degree rather than taking up a program on pure BS data science or Bachelor of Science in Data Science?
This is at FEU?
I am not sure.
I guess it's a little bit hard to know without knowing the curriculum.
Right.
Right. It's hard. It's a bit hard to know without knowing the curriculum of what is the difference between having it as a track specialization on top of a math degree and then having it as just a pure focus. Like, what's the incremental add of having it as a pure degree, or what topics are you covering? But definitely, I think as a general rule of thumb, having a strong math background is very helpful to becoming like a full-fledged data scientist. So that's just, it's a non-commitmental answer, but that's because I don't have enough data on your situation.
I see what you did there. Okay. Okay. Perhaps 2 more questions. Is that okay, Angela? Before we wrap up. Okay. How can nonprofits who usually do not have funding allocations for data analytics benefit fully from data? So I think this is a question not only for nonprofits, but also for perhaps startups or medium-sized enterprises. So companies who don't know the importance of data yet, right? How can they fully benefit from data science?
So honestly, the short answer is they can't. And that, I know, seems kind of harsh, but before we can get to the point where we can have like data science processes in organizations, we need to have buy-in from senior people.
Right.
To have awareness from leadership, and we need to have them validate the importance of data. And if they don't see the importance of that, then they can benefit from it. And that's the thing that we want to solve, right? Like, that's the thing that we want to, on an individual basis, also on team basis, like, have people become literate and understand the importance of it. Then that unlocks the opportunity for them to engage with it.
Yeah.
So there's a little bit of an advocacy part of that.
Yeah.
But I mean, as you guys saw, like in the data science process, you can't just jump step 1, step 2, and then go to step 3 or step 5.
Yeah.
So if you don't have the data, then you can't start. It's just a sequence of events, right? So you need to, I mean, in the very beginning, you need to like be aware that it's important. Then you need to set up a data strategy and find a way to be able to capture data, whether that's through surveys or whether or not that's existing stuff that organizations already have, but they never think of it as a resource. You know, like companies think of like cash balances, let's say it's an asset, right, on your accounting balance sheet, but they don't think of data as an asset. So because data is not viewed as an asset, it's probably everywhere, right? It's like in this file, it's in another file, there's another version of it somewhere, and it's not organized. So before they can fully benefit from it, first they have to see the importance, and then 2, they need to start getting the data and start trying to organize it in a way that is relatively clean, so then it could be ready for the analytic process.
Right. Okay, thank you very much, Angela. There's some questions here, and perhaps you can just send it to the Innovation Center and we can forward it to Angela. But our time is limited. We do hope that we have more time with Angela, but I'm sure she's also very busy running her company. So perhaps any last words, Angela, for everyone who's watching here, who are, I think, all of them, the reason why they're watching is because they're interested in data science, what it's all about. Any sort of inspirational or parting words for them?
Yeah, sure. I'm like so happy that there's so many people who are interested in this, and it doesn't matter if you go on and it doesn't matter if you need to become like a full-fledged data scientist. But as we spoke about, the idea of data literacy, the idea of asking questions, of being critical and being curious is a core part of what it means to be a human today. Like, that's my personal opinion. And so I know one question was around like, what makes a good data scientist, right? So one other thing I guess we didn't really touch on is this idea that technology is changing so quickly. There are always new tools that are being established. A part of also being somebody in this field is continuous learning, like lifelong learning. That there's never like, hey, I did this BS in data science, I'm done. I'm certified, I'm good to go, and people should see my value. Fortunately, unfortunately, that's not how it works. And truly, like, if you enjoy learning and the process of discovering new things, then this is like definitely not just the trait of a successful data scientist, but the trait of a successful person, right? And ultimately, that's what Eskwelabs wants to grow, for people to fall in love with the idea of learning and then keep on doing that. And so those two things that I mentioned that, we really invite you guys to come and participate. One is a free learning course around Python, and then the other is a Data for Good hackathon if you're interested in experiencing for yourself what building a data project is like.
Cool. So there are a couple of questions. Question about how they can join the hackathon. So I think.
Sure. So just come to our Facebook page, maybe follow our Facebook page, and in I think 2 days' time we'll release the sign-up form for that, and there will be details around how to join and what's needed. We will have a launch event next Saturday with data scientists from the UN who will talk about how they use data in their organization, how they use data they collect from country governments to predict their progress in terms of the SDGs. And then for the hackathon itself, you will have 1 week of time to work on the project, which the prompt you will get at the launch event. It is a group project, so do find friends who want to join, and it would be a much better experience to do it with other people rather than yourself. So then you get an opportunity to present to the bigger audience, to like a data science community and the data team at the UN SDSN, and the winners will get mentoring hours from the data scientists from the UN, and then the top team will be shortlisted for a future Data for Good scholarship at Eskwelabs, where you will get a free ride scholarship to go through the entire data science program.
Okay, all right. So perhaps we can get in touch with you through Janina. We'll blast it in our Facebook page, in our distribution channels for information. Okay, so turning it over to our host and our programs officer for the Innovation Center, Janina.
Thank you, Angela and Roland. I know 2 hours is very short because Angela will still have a lot to share, but too bad our time is very limited. But we hope that this was at least a good platform to start more conversation and collaboration. But before I let the both of you go, we would just like to ask again Roland to present our certificate of appreciation to our speaker this morning, Angela Chen.
Sige, how are we gonna do that? Virtually?
I think virtually.
Okay, yeah, okay.
I think Jason is going to flash it all.
Okay, sige, we'll flash it then, Angela, a few minutes, then I'll...
Thank you so much for this period.
Yeah, so, ano ba to, share?
Guys, really appreciate you inviting me.
Of course. Thanks for your time, Angela. I know you're very busy, but thanks for your time to talk to us. No? Okay, so FEU Tech and the FEU Tech Innovation and Entrepreneurship Directorate presents the Certificate of Appreciation to Miss Angela Chen, CEO and co-founder of Eskwelabs, for selflessly sharing valuable insights and providing inspiration to the FEU community during the TechX, the importance of data science in the fourth industrial revolution, signed by myself and the Senior Executive Director for FEU Tech, Dr. Benson Tan. So thank you very much, Angela. So we'll just email this to you. This is the new normal of certificate
Thank you.
giving.
I'm accepting it.
Thank you.
Yeah, thank you very much. And do keep in touch with us for those of you guys who are students. We're very happy to continue to inspire you and give you resources on your journey to learn.
Thank you, Angela. Okay, Janina.
Again, thank you, Angela. And we would also like to thank a few more people for their support, especially for this event. Earlier this morning, Attorney Gianna Montinola, the Senior Vice President for the Corporate Affairs of FEU, joined us. Of course, Dr. Benson Tan, our Senior Executive Director. Mr. Prem Paipon, Asian Institute of Management, Dado Banatao Incubator Executive Director. And of course, to ensure the seamless live streaming of this event and our tech support, the FEU Tech Computing Services Office. We would also like to thank everyone who attended this year's first TechX event. So this will be a regular session every first Wednesday of the month. We encourage everyone to follow us on our official Facebook page. So we will post there all our event announcements and updates. So it's at FEU and Innovation Center. Let me also remind everyone to please complete our post-event survey to claim your digital certificate. See you in our next event, Unmasked, happening on August 19, where we are going to feature another inspiring tech entrepreneur. Again, I would like to thank everybody for participating and have a good day.
Thank you.